Hello. Okay. So in the today's class, that is the so everyone have joined. Okay. So now today I want to that is the explain that is the uh, new chapter, that is the data and the signal. So you know the OSI model and the different type of layers and their working functions. Now, so this is the your physical layer part. So in the physical layer, how the data will be communicated, or you have to convert your data to your signal or signal to data. Okay. So and type of okay, with the analog format, or it may be a digital format. So in the analog format, so what happens in the analog format? One. Okay. So in the analog format, so analog or digital format, so how it is possible now your data can be moved from the analog to digital or digital to analog, because when the data is coming from the via the wire, so this data is called your analog data. Now you have to analog means that actually the data should be your continuous. Okay. So now you have to continuous data, we have to convert it into the discrete state. So this discrete is your digital format data, that means the 1 or 0 format. Okay. So in the discrete format, there is the 1 or 0. So now 1 means that your positive signal, that is and 0 means that your that is no signal. Okay. So now you have to go, that is the formation of the bit of the data, 0 1 0 1, just like this. Okay. So now, so this is your digital format. So now how to possible? So how to convert your digital to analog and analog to digital? So how it is possible? So this will be discussed. Okay. So there are first part is your conversion from your analog to digital data, and the second conversion is the digital to analog, the different type of signals. So different type of periodic or non-periodic signals. So to be discussed. Okay. So now you know that the data can be your different type, analog format or digital format. Okay. So this all we will discuss. So you see in this example, so this is the
Sir, can you
your
please
data.
rotate your phone?
Hello.
Yes, sir. Can you please rotate your phone?
Repeat.
Yes, sir.
The screen is not visible. Screen is.
Sir, if you will rotate it, then it would be better, sir.
Yes. Hello. Hello. So this is not visible. Now it is okay. Okay. So now you see that is the your this conversations. So this part, okay. So now you see, so this is the your signal formation. So first one is your analog signal. So analog signal is actually the wave format data, okay. So that wave is that it may be that have three parts. So some part is the, that is the positive signal part. The arrow line, that is x-axis, is that your zero, and the below side is called the your negative. So that the pulse will be the three types: so positive pulse, zero pulse, and the your negative pulse. Okay. Now your, so this is your analog signal. Now this signal will be converted to your digital signal. So it is a your analog part is your continuous. You see that is the continuity, but in the digital, so that will be the discrete format. Okay, so you see if the timeline, so the signal is some of the time that is the your within the range from 0 to 1. Okay, so now here we have to we have to take the higher pitch. Okay, and this will be the your discrete format. Okay, so other will be left. Okay, so now so actually the
You are not audible. You are not audible.
non data non-periodic. What is periodic? Periodic, your periodic signals, periodic analog signals. So periodic means that what? Na, after certain amount of time, so this will be commonly repeated. Okay, suppose the your 0 to suppose the 2 seconds, so there have the signal your positive 5 volts, and then our again to the another the 2 your time slot, that is our again the 5 plus volt will be there. So this, if this same type, so this is called the your periodic, and non-periodic means they have not sequence. Okay, so first is the same signal, then again the 2 times turn, then again same signal, then again the next time turn, there is again the repeated the same wave. Okay, so if it is happen, so it is the periodic signal, and if it is not happen, so that is the non-periodic signals. So up to this is clear, everyone? Hello. So hello. So periodic and non-periodic signal. So now in the
Yes, sir.
periodic analog signal, so in the periodic analog signal will be classified, that is the your two part. That is the one part is your the simple, and another is your composite. Okay, so simple periodic analog signal is that the that is actually the look like the your sine wave. Okay, sine wave or cos wave. So you know that the positive 5 volts, and then after the second period the same will be repeated. Your sine signal, you know the sine cosine signal. Okay, but composite means that, so when the two signal will be merged, okay, so this is called the your composite signal. So when the that is the first signal and second signal both are would be the merged format, and then it will be the simplified signal. So now this signal is called the your composite periodic analog signal. Okay, so composite of the your multiple sine wave is also there. Now, so now you see, so this is your sine wave. Okay, so you see, so that is if the one times 10, then the two times 10. So they go, you see that is the same. Okay, the sequence is the same sequence. Okay, so after the one, then the positive, then the negative, then our again positive, then the negative, again positive, and again negative. Okay, so it's happened. So it's why it is the periodic. And the mathematically we have to express the, that is the your some of the cases it is the 155, for example of the 155 to 170 volt. Now in the commonly used, so this will be repeated. Okay, now the next part, that is the your
two signal have the same phases and the frequency but different amplitude. There is
Sir,
in the
someone
two
wants to join
signals.
class.
Yes, yes, tell me.
Sir, someone wants to join this class. Please accept their request.
Okay. So all have joined. Okay. Now you see that is there are the two signals with the same phase. What is the same phase? What is the phase? Phase means that there is the 0 plus 90, okay, 180 and 270. So these are your phases. So phase, same phase. That means that there is a positive phase or there is a negative phase. Amplitude and your frequency okay. So your x-axis, so this bar is called your frequency bar. Okay, amplitude is your y direction. So you see the amplitude will be the decreases here, peak amplitude, but the same phase and the frequency also same. Okay, and you see the positive, then negative, then positive, then negative. Okay, so this way the wave will be formed. So and the next signal, so the same phase, but the frequency and the your amplitude is the different. Okay. So now, the second example, the voltage of a battery is a constant with the constant value can be considered a sine wave as we will see the later. For example, the peak the values of the of an A battery is normally that is 1.5 volt. You see, so in our what is your it is normally 1.55 volt. Okay, so this is an example. Okay. Now second part that is your frequency. So in the frequency, so you know that frequency is the one. What is the formula? So that is time period. So time frequency equal to 1 by t. Okay. So that is the time period. So and the time period equal to so inversely proportional to your frequency. So that is the frequency and the time period both are inversely proportional. Okay. Now, in this sign, there is a two signal with the same amplitude. There are two signal at the same amplitude, but other phases also, but the different frequency. So frequency you see. So in the first phase, the frequency is the that is the total time taken. That is the 12 second. Okay. In the first, what is the frequency? Frequency is that the how much time will be how much for the time period, that is the how much time. Okay, what is the time period? Time period is the how much time will be after that will be same repeated. Okay, you see, so that is a positive sign and then the negative, then again the repeated positive sign. So this time from the 0 to your next, that is the same peak time. Okay, so this is the taken the 12. Okay, 12 seconds. So the time period equal to 1 by 12 seconds. Okay. So 12 is the unit period. But in the second example, so here the time period that is the 6. Okay. So that should be the double. So that's why here the frequency are the your different. Okay. So frequency are the different. But the amplitude, you see the amplitude, the peak is the same. Amplitude are the same, and your phases, the positive phase and the negative phase. So both will be the same, but the frequency are the different. The first one, the first that is your example is that the amplitude are the different, but the frequency and your phases are the same. But here the amplitude same and the time your phases are the same, but the frequency are the different. The first frequency is here, for example, that is the 1/12, and second that is the period is the 1/6. Okay, so after this is clear, everyone. What happens? Hello. So here, how much frequency? So what is the frequency? In the first example of the year, that is 12 hertz. The frequency is 12 hertz, and second, that is the frequency is the 6 hertz. So why 6 hertz?
Because time period is double.
Yes, time
So
period.
6
That is
periods
the
in
total
1 second.
time period. That is the your here the you see that is the 1 by your 6, and here the 1/12. Okay, so those both of the frequency are the different. That is your time period and frequency are the different, but the amplitude you see that is the same. Okay, amplitude value, peak value and amplitude, these are the same. These are the units. Okay, so hertz, kilohertz, you know, I think everyone knows. Okay, megahertz, kilohertz. Okay. Now this is an problem. Okay, so the power home has this frequency is 60 hertz, and can be written means that 1/f 6 milliseconds. Okay, pure. So you know the time period equal to 1/f. So 1/60 hertz. Okay, now it will be convert. That is will be the second format, and then you have to find out the total time. That is the 16.6 mm. Okay. Clear?
Yes, yes.
Yeah. Okay. So next example, there is the your time period is the 100 100 milliseconds. Okay, or 100 microseconds. Okay, so 100 m is the 100 microseconds. Now we have to find out the microsecond. You know that, I think microsecond to your millisecond to your microsecond conversion. So I think you know. The period of a signal is the 100 ms. The period of signal is 100 ms. So what is the frequency of kilohertz? What is its frequency in kilohertz? So time period दे दिया है ना, time period is the 100 ms. Now you have to find out the frequency in a kilohertz. So you know that 1/f equal to 1/t reverse way. Okay, now you have to put down, and then you have to find out the kilohertz frequency. Okay. Is it clear?
Yes.
So same. That is the previous one the time period, and this one the frequency. Okay, the frequency is the rate of change of rate of change with the your respect to time, and you know that. Okay, now, and the signal then does not change the all value. Actually, the frequency, if the frequency is 0, okay, if frequency 0 means why the signal does not change at all, its frequency is 0. Why? Or the if the signal changes the instantly and the frequency is infinite. You explain. So signal is not, the signal does not change at all, its frequency is 0.
So if the frequency is 0, so what will be the time? What is the your time period?
Finite.
Infinite.
Infinite.
So that is infinite. That would be not change. Same way. है? If the signal change instantly, then its frequency is infinite. So it change means that will be the time period is the 0. Okay. And then your that is the frequency will be the infinite. Okay. And it is also the phases describe the positions of the wave. I have already explained that previously. And relative to time 0. That means that initially that should be the your 0. Okay. Then the your positive or negative, or the reverse side, that is the if it is the 180, this is the negative side on the x-axis. Okay. 0 means that x-axis, then 90 degree positive. Okay. Then the left side, that is the your 180, and your negative side also, that is the 227. So the phases is describe the positions where the waveform is there. Okay. So which coordinate where the your waveform is present. So it is the depends on the time. It started why it is y-axis. Okay. So and the minus 180, that is the your this side left side. Okay. So this is happened. Now you see, so this is a another problem.
আগে
So
এটা একটু
a
বলবেন,
sine
শোনা
wave,
গেল না, ভয়েস কেটে গেল।
হ্যাঁ বলতেছি তিনখানা there are the three example. Okay, so phase. Okay, phase means as 0, 0 degree, 90 degree, 180 degree, and 270 degree.
আচ্ছা,
Okay, so if the 0 degree, so you see what happened. So it is starting from like the 0 coordinate. For the example 1, 0 coordinate থেকে start হয়েছে। 90 degree, it means that 0 1 মানে actually আমি coordinate বলছি এটা বুঝে যাবে বলে y axis থেকে start হয়েছে।
আচ্ছা, 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 হ্যাঁ
It is
বুঝেছি।
starting from y axis. Okay, মানে এটা বোর্ড হলে আরো ভালো বুঝানো যেত এখানে। And C, if it is C is a 180 degree, it is starting from the down মানে negative your কি বলবো negative phases, হ্যাঁ negative y axis it starting from, but starting from the 0 because 180 মানে 0 right না, 270 that is starting from what থেকে হবে মানে 0 minus 1 বুঝে গেল, 0 minus 1 পয়েন্ট থেকে starting from 0 minus 1. Huh? Okay, so now this is this waveform actually, and these phases. Clear? Clear? Huh? Okay. Now this is a problem. Okay, so you see a sine wave is offset of 1/6 cycle with respect to time 0. What is the phase in degree and radius and the actually the radiations? Okay, so that is the you know that your complete cycle actually that is the 360 degree. So you know, है ना, যদি আমার যদি ये कोई coordinate হয় 360 degree coordinate তো 0 থেকে start হয়, then 90, then 180 to 70 and 60. So now one of the 6, that is the 60 degree, है ना, তো radiation হিসেবে বার করতে হবে 60 degree into 2 pi by 360 আমরা জানি 2 pi divided by 360 rad. Okay, so pi by rad. So if I put pi value, that is a 22/7. So this rad value is coming. বুঝে গেল? একটা পুরো কম্পিউটারে আমার 1/6 টাকা আমি নিচ্ছি, 1/6 of cycle. So total cycle is the 360. So 1/6 by 360 degree. So 60 degree actually, है ना? So 60 degree का जो radius हमारा जो degree है 60 degree, and the value of the degree is a 60. Now you have to convert to rad.
So that is 2 pi by 360. So 2 pi by 360, there is the pi by 3. So if I put the pi value 22 by 7, so pi means the 22 by 7. So if I put this, so 1.046, and that value is coming. You calculate this. Clear? Okay, clear? Is it clear?
Yes, sir. It's clear.
Okay. Now the wavelength and the period. Wavelength and the period. So actually, if you know the period means that I have already tell you that is a similar wave. Okay, that is the starting point. So that is a if there is a your transmitted medium, so you have to start from the your t time. Okay, so transmitted the wavelength is starting from the t time. Now the next time period will be the t plus t. Okay, so that is if you start is from the plus t, that time period wise. So this wave actually, one wavelength actually the within the time period, within the time length. So ending frequency difference টা হচ্ছে wave. Okay, so wavelength is the difference between starting and ending frequencies within the time period. So এখানে t যদি টোটাল টাইম পিরিয়ডটা হয়, তো t প্লাস স্মল t প্লাস ক্যাপিটাল t. ওকে, সো এর মধ্যে যেটা হলো সেটা হলো অ্যান্সার। ওকে, তো এখানে দেখো এখানে বলেছে যে যেটা হচ্ছে যে এ টাইম ডোমেন এন্ড দ্য ফ্রিকোয়েন্সি ডোমেন plot with the sine curve. So total frequency বলছে total এটা 6 hertz frequency. Okay, so এখানে peak value হচ্ছে peak value that is the 5 volt. So this is the amplitude. Okay, so 5 peak value 5 value, and আমরা এটাকে যখন ডিজিটাল এতে কনভার্ট করব, when we convert to digital, then we have to consider the only the 5 volt. Okay, and that is the, so 5 volt actually the peak value and frequency is the amplitude. 5 volt actually the your amplitude, and the total is length actually. Y axis was time, that is the 6 hertz, yeah, which is the length. This is another example. Okay, so now, so here you see in this example, that is the time domain and the frequency domain of the 3 sine wave. Okay, so there are 3 colors, there is the 3 waves. Okay, so that is that, and they have to different, that is the your amplitude. Okay, amplitude are the different. So first one is the frequency is the your 0. Okay, first the frequency is the 0, second frequency is the 8. Okay, and third one the frequency is the 16. 16 means that within the one time. Okay, so total how many frequency is there? That is the 16 your peak is there. You call it, that is the your color, your green, not green, so green type color, and the your, that is the your pink color, that is the your 8. So total 8 peak. You count this 1 2 3 4 5 6 7 8. Okay, so the frequency of this 1 by 8. Okay, and your 16, the 1 by 16, and the your blue, so blue color. So here the you see the frequency is the 0. Okay, now in the next side, that is the your frequency wise. Okay, so in this frequency, so that is the your 0. Okay, so amplitude is the 15. So amplitude here 15. Okay, so in the 15 you have the one straight line, so 15, and the 8 signal your the amplitude is the your 10, and the frequency wise, So 16 is the 5. Okay, so different amplitude, different frequency wise, and within the time domain. And the three sine wave will be the mark. It's a very skill fragment. So when this type of actually the three signal or three wave will be merged, so this will be the created composite periodic signal actually. So this is happening. So when suppose we have considered the only the hierarchy as well as the we have first consider hierarchy and then where this would be merged. Okay. So now so this type of your signal will become. Okay. So that is the your uh, three signal will be compound. Okay. And then so now this type of signal is called our the composite signal. If you in this you see in this exam in this diagram or in this signal, so here the 10 your frequency 10 your 1 by 8. Okay, so amplitude is the 10 is also there, amplitude 5 is also there. Okay, and the 15 is also there. Okay, now here there okay, next is the grain, so there is 3 times, and that is the 9 8. Okay, frequency. If the frequency will be increased, then and the time period is the same, then your amplitude will be the different. Amplitude will be increased. Okay. Now when it will be merge it, so now some of the case you have to consider the positive, some of the case you have to consider the negative. Okay. And when the upper cut or lower cut have happened, now this will be the created uh, different type of signal, or the distortion will be coming. Okay. So this is your distortion. Okay, so that you see. So if that is your signal type, now you some of the that is the wave will be coming the your high peak, and now some of the will be the distortion will different type of will be within the time domain. So different type of amplitude and the frequency will be there. Okay, so this will be create a problem. Now the bandwidth is the that is the your higher frequency and the lower frequency, the difference between higher minus lower. I have already told you. That is the this is the your bandwidth. Okay, now within the bandwidth, so you know that the our bandwidth, so any signal bandwidth. Okay, so that is the range. Okay, actually, so this is the 500 hertz to your one your 5,000 to your 1,000, and this range. Within the range, some of the signal is coming, then it will be added. Okay, so this is called our bandwidth signal, and this bandwidth equal to there is difference between this higher minus lower frequency. So now this is another program problem. So if the periodic signal is the your decomposed into 5 sine wave with the frequency 100, 300, 500, 700 and the 900. So what is the bandwidth? And draw the spectrum. Assume all the components have a maximum amplitude of 100 volts. Okay, this is our problem. So now in our signal, what is the total? How many signal is there? Total 5 signal. Now in the signal, so 100 is the lower frequency and 900 is the higher frequency. So what is the bandwidth? So this difference. Okay, so 900 minus 100, that is the 800 is our frequency. Okay, clear? Now in the spectrum, that is the how many your that is the peak is there? That is total 5 peak. Yes or no? Total 5 peak. Now you see the spectrum. So this is our spectrum. Now in this spectrum, so 100, 300, 500, 700, and the 900. And this bandwidth difference is the your 800. And if it is the all are the that is the your amplitude is the 100. Okay, so amplitude 100 means the maximum amplitude 100 that is the your amplitude value. Okay, so this is the 10 volt amplitude. Okay, so now this is our spectrum. 100, 300, 500, and then this is the spectrum. And this difference is the 800 kilohertz. Okay. Yeah, this problem. Hello. Is it clear bandwidth?
Yes, sir. Yes, sir.
Okay. So bandwidth is the difference between higher frequency minus or lower frequency. Okay. Now second problem. So a periodic signal has the bandwidth of 20 hertz. Okay. Now the higher frequency is the 60. So what is the lower frequency? What is the lower frequency?
40.
60 minus 20, that is
40.
40. 40. And draw the spectrum of the signal. Okay, and contain of the frequency of the same amplitude. So this is easy problem. Okay. Now this is the draw the signal. So 40, 41 to your 6. And this is the now with the middle frequency of 24 and the two extreme frequencies of 0 and draw the frequency domain of the signal. The bandwidth is how much? 200. And the middle frequency, the middle portion of the frequency is the 140. Okay. So higher frequency cover signal. What is the higher frequency? Hello? Higher frequency? Middle is the middle, that is the 140. 20 is your bandwidth. So in the middle is 140. So 100 is the left 100 is the left side and another 100 for the higher part. So 140 plus 100. So 240 is our higher bandwidth. And lower bandwidth will be 140 minus 100. So 40 is the lower bandwidth, lower frequency. Okay, so lowest frequency is the 40 and highest frequency is the 240. And your peak amplitude is the 20 volt, that is the amplitude value. And some of the two extreme frequency have the 0. Okay, and so you see, so that is the extreme frequency, that is the 0. Okay, 40 and 240, and extreme frequencies is the your 20 volts, your peak value. So 40 at the place of 40, that is the 0 frequency, and 240 it is also 0 frequency. Okay, so this is the spectrum. Yeah. Hello. It's clear. Okay. This is another example. So the periodic composite signal is the signal of the propagated. Okay. That is the AM radio stations. And you have to practice it. Okay. So this example you have to practice it. There's so many example is there. So now the second part of our this is your digital. So up to this your analog part. Now your digital part. So in the digital part, so you know the analog, actually analog to convert to your digital, or the digital to make analog to. So in the digital signal that have only the two values, your discrete way. So one value that should be that is one can be encoded to positive volts, and another value is the 0 value. So 0 means that you are 0 volts. Okay. So two we have treated as a 2. So 1 and the 0.
Okay, so this is our digital signal. Now how to convert the this your digital to analog or analog to digital, so this will be discussed. And you have to remember, so this some of this signal, suppose it will be the 1 or 0, so when you store it, so that should be take the 1 bit of memory, actually the 1 bit. Okay, so some of the signal is the, suppose the 5 volt, so that should be 1, so it will take the 1 bit. Okay, now you see, so this is the your digital signal of the label. Okay, so is it clear? So you see that is the 1 plus 5 volt, that is the label 1, that is the your timeline. Label 2 is a plus 5 volt. Okay, and if it is, so it is 0, that is the 1. Okay, and you see, so the this is the your 0 part. Then the second page, each and every time slash. Okay, so that is the 0, then the 1, then 1 plus 5 volt, then the again the 0, that will be downward, 0 0 0, and then 1. So it's 5 volt amplitude. If the 5 volt amplitude, that is the signal. If the level 0 means the 1, level 0 is the 0 volt. So if it is 0 volt, therefore you will see this line is the second time to line, that is the 0 part. Okay, so that's why it is 0, then 1 1, then our again 0, then 0 0 1. Clear? Hello, it's clear. So you draw this signal, this picture in your copy. The figure number 3.16 of A. So you have to split it into dotted way. Okay, so you have to divide it into, that is the your some of the time frame wise. Okay, now in the first frame, the signal is the plus 5 volt, pink line. So if it is a plus 5, that is the 1. Now then the second frame, that is the again 0. That is the 0 means that the level 0. This horizontal, actually you only consider the your horizontal line, not vertical. Okay, horizontal line. So therefore you see the first time slash, that is the your horizontal line 1, that is the level 2 position. Then the level 1, that is the your 0. Then again it will be fixed. Okay, now in the third, that is the level 2 horizontally. Okay, then our again next part, that is horizontally, so both 1 1, then 0 0 0, then 1. Okay, clear? Hello.
Yes, sir, clear.
Okay, that means that your horizontal line is which level? If it is a 1 level, that is 0. If it is level 2, that is the 1 actually. Okay. Now in the fourth level wise, okay, so I have the fourth level, level 1, level 2, level 3, and level 4. Okay, so actually that is the number is the 2 number positions. Okay, so here only the one bit, one you have to, but here the 2 bit wise. Okay, so that means that if I
apply the permutation combination of the 0 1. So what happens? 0 0 0 1, okay, 0 1 1 0 and 1 1. Now if the our signal we have to represent the 0 0, if the line is the level 1 positions, then we have to put the 0 0, then the 0 1. If the line is the your level 2, then it is the 0 1. If the line is 1, that is the level 3, that is 1 0, and if the line is the level 4 horizontally, then the 1 1. So you see in this that is the signal, periodic signal Y. So in the digital signal, so first is the, you see, that is the horizontal line is the which level? The horizontal line first, that is the level 4. Yes or no? Level 4. So that's why it is the 1 1. Then the second sector, that is the level 3. That's why it is the 1 0. Then the level 2, always. So if the level 2, so it is 0 1 0 1. Then you see that is the 0 1, that is the level 1, 0 0 0 0, the 3 phase. Then again the peak, okay, and the level 3. So in the level 3, that is the 1 0, so 1 0. So total signal, if I collect this, so 1 1 1 0 0 1 0 1 0 0 0 0. So total your signal,
Your voice is breaking.
so first one is the 2 level wise, and the first one is the 2 level wise, and second one is the 4 level wise digital signal data. Okay.
এমনি তো 2 লেভেলেই সব কাজ হয়ে যেত, তাহলে 4 লেভেলে কি
Yes.
দরকার ছিল? ডেটা পাঠানোর জন্য
না,
2
4 level
লেভেলে
means that হ্যাঁ ইয়েস, বিকজ যেটা হচ্ছে আমাদের ডেটাকে আমাদের কম্প্রেস করার জন্য, সাপোজ ধর এখানে কি হচ্ছে, এখানে দেখ 1 1, ইন দ্য ফার্স্ট ওয়ানে দেখ 1 0 দেন 1 1, তাই না? তো আমার কি হয়েছে, একসঙ্গে একই সিগন্যাল আছে, তো এটাকে আমরা পেয়ার ওয়াইজ করছি, পেয়ার ওয়াইজ। ওকে, যে যদি আমার 1 1 আসে এক ধরনের করছি, 0 1 আসে এক ধরনের করছি, এটা আমরা পেয়ার ওয়াইজ যদি করি, তো সেক্ষেত্রে আমার এরকম নেগেটিভ সাইডে আমরা দুটো পেয়ার করলাম, পজিটিভ সাইডে দুটো পেয়ার করলাম। তো আমরা এরকম ডেটাকে নেওয়ার জন্য পেয়ার ওয়াইজ যদি কোনো ডেটা আসে, তো সেটাকে রিপ্রেজেন্ট করার জন্য 4 লেভেলে এটাকে আমরা নর্মাল লিখতে পারি।
আচ্ছা,
ঠিক আছে। So this is the example. Okay, so we have to type this is problem. Okay. Okay, so this problem, that is the assume we need to download the text document at the rate 100 pages per minute. What is the required bit rate of the channel? So 24 lines is there with the your 8 bit. This is incompleted question. Assume that the text document at the rate 100 pages per minute. Okay, 100 pages per minute. What is it? But what are the line and character is not given here. Okay, so there have the 24 lines. These pages have the mention is not mentioned. So that is the 24 lines and the 80 character. Okay, so that means that if pages have the 24 lines and 80 characters, so if I multiply this, okay, 100 into 24 into 80, so total how this much your character is there, and you know that each character takes the 8-bit data. So I think you know, everyone, the character takes the 8-bit, right? So total how much bit? So this will be calculated, which bit will be there, and it will be, that is the total time will be the 60 minutes per minute. Okay, per bit, so that will be divided by 60, and this is the your bit per second. So what is the bit per second? Now each second how much bit of data will be passed. So this is called the bit per second. Okay, so this is called the BPS. Mbps is the megabit per second. Per second, how much megabit data will be passed? So this is the megabit. Now this is the
your find out the your bit rate. Okay, so 24 into 80, that is the character, and yeah, total 100 pages is there. Okay, so 100 pages, and each pages are the 24 lines, so 100 into 24, and each 24 line with the 80 characters, so 24 into 80. So and each character will be take the one bit, so it will be multiplied with 8. So total this much bit actually. Okay, and it will take 60 minutes. Okay, so if you find out to 100 minutes, so that will be divided by 60, and then this is the your bps, and now from the bps we calculate to mbps. Okay. The same way. Okay, so we have to calculate the kbps also. So here now your voice channel of the 4, that is the your digitized, that 4 kilohertz your bandwidth analog signal. So bandwidth is also there. Okay, now from this you have to find out the 8 twice highest frequency of the 2 samples, and we have 2 samples will be required the 8 bit. So what is the bit rate? So that is the your total bandwidth is the 4 kilohertz. 4 kilohertz means the 4000, and each of the kilohertz, so the total takes the your 8 bit data. Okay, so actually the each sample will be 8 bit, so it will be divided by 8 bit, and 2 samples per hertz. Okay, so it will do 2, so total this much bps, that will bit per second, calculated. Now from this you have to calculate kbps divided into bit to kb sample. Okay, so these are the frequency domain wise, so your periodic signals. Okay, so this part is completed. Now come to the your transmission medium. Okay, actually this is the picture is the for the one is the sender and the receiver. Now the sender will send the data or the digital format or the analog format. Now via the channel the data will be sent. Okay, so now this channel is called the your medium. So this medium is the transmission medium. So there are different type of transmission medium is there. Oh, yeah, it is not good. There are so many problems there. Okay, so that takes up much more time. So you try to practice it. Okay, I will give the I will solve the 1 or 2 my problem. Now you have to try to solve this. Okay? So I will provide I provide this note. Huh? Yes. Hello. I also give the slides in, maybe it will be preferable for in the WhatsApp group. Okay, so I'll send you in your WhatsApp group. Okay, should be better. Okay, because there is so many problem is there, and you try to practice it, and this will be easy problem, not a hard problem. So you have to practice it. Okay, so if any problem will be arise, okay, but if you any doubt or any questions will be there, now I can explain. Okay, so you will mark it, and then the next class I will solve this. Now these are the problems. Okay. Now your transmitter importation. So when the signal when the signal will be passed, so there are different type of problem will be arise. So problem means what the noise, attenuation, and the distortions means that your signal may be. So what is the noise? So unexpected signal will be added with the main signal. মানে हमारा जो signal दे रहा है, suppose I am talking to
I am taking your class. Okay, so when I'm talking to you, so that has the frequency. Okay, I have sent the frequency with and your receiver, that is your yeah, and you can um, receive the our frequency. But when I'm taking the class, so your some of the friends will be the talking. Okay, so that time our frequency will our frequency of the voice that they have the signal. Okay, so that should be added with our your friends, that is the talking frequency. So then this will be created noise. Okay, so that is the unwanted signal, but expected signal will be added with the main signal. So that will be create the noise. Second one is the distortion. Distortion means that when I'm talking something that are the frequency, so some of the weather reasons or some of the problems, so that frequency will be changed. It may be it from the sound of distortion. Okay, that is I will define type signal. Okay, so this is create the distortion. And attenuation is the attenuation is the that is the your either frequency will be high range. Okay, and or the frequency will be lower range. Okay, so this is happening. So so there is the your implement the cases, there is the impediment cases, there is the attenuations, distortion, and the noise. So attenuation means that you see, so this is the our main signal, original signal. Okay, so now in the point one, so that should be the, it will be the minimum, that is the attenuation will be added, so it will be minimum and it should be, then the our original signal will be added, then it will be the amplifier. Okay, so it will be create the higher signal. जो सिग्नल है उसके साथ एटेन्यूएशन होके वो एम्पलीफाई हो गया. So now this type of cases, so this type of problem is called the attenuations. Okay, that means for example, so this should be calculated by P2 by P1. So P2 means that what is P2? Now P1 is your original signal. Now P2 will be the your after attenuations. Okay, signal is the P2. So here, so the formula is log of, you remember this, the log of log 10 base log P2 by P1. Okay, so this is your attenuations. So you see in this example, so in our signal in the transmission medium, the power will be reduced to half. Okay, so if the it may be, I have already telling the, it may be reduced or it may be increased. So it may be suppose 2 times, suppose that will be higher, it may be half. Okay, so that's what happened. Okay, so here the it will be distortion, that it will be half, it will be the our power that will be reduced to half. Okay, so P2 equal to, what is the P2? P2 equal to P1 by 2. Okay, so now you see that is the log of 0.5 of base 10 of 10 base log of 0.5. Okay, now in the using the formula, so this is the minus 3 dB. Okay, so that is the your loss of signal, that is the minus 3 dB. Okay, that is the half of the power. Now here the your it will be amplified, that is the P2 equal to 10 of P1, है ना? So P2 value is the 10 of P1. Okay, so that is a 10 dB. So that is 10 dB. Clear? This example. So 10 log base 10 of P2 by P1. Here P2 equal to 10 P1. Okay, so I put to that the place of P2, that is 10 P1 by P1. So that is 10 log of 10 base 10. Okay, so log 10 of 10 is the your 1. So that is a dB. Okay, so 10 dB. 10 decibel. So this is the minus 3 and plus, that is minus 3. Okay, so now it will be plus 100. This is the example. So you have to solve, you have to see all the problem. Okay, now the distortion portions. So in the distortion, So this is the composite signal. So actually composite signal, that is the main signal is there. Okay. That is the main signal, and that is a small other signals, and there is signals. Okay. Now when the sender will be sent, okay, when the sender at the sender end, so now it will be uh, the main signal added with the your composite all the phases signals. Okay, now it will be create a new signal format. Okay, so at the sender part, and receiver also receive this, and after receiving they have to exclude the other signals and have to receive the main signal. So this is happen in the distortion process. Okay, so you see this is the your actually main signal, the point one. Okay, now the using the noise or the some the problem that is the your unwanted signal. So via in any of the regions. Okay, that may be the regions of weather, that may be regions of transmission medium. Okay, so now the noise, that is the unwanted signal, will be added, and the point two, that will be the receiver receive the other signals. Okay. Now in the that is the your noise ratio. So we have to calculate the different type of, you know, that SNR, okay, or SNR dB. So I think they have any idea the digital the analog to digital conversion. You know, you know.
But again, your voice is breaking. Not, you are not audible probably.
Okay. Okay, so in the Nyquist theorem, so in the Nyquist theorem is that bit rate agreed with the your intuitive bit rate and with the your baseband. Okay, so in the Nyquist theorem always says that okay, after this is how much time? Okay, 344. Okay, so you see this problem. Okay, then next step I will explain the your this Shannon's theorem. That is the formula actually. So this formula is the C equal to B log base 2 of 1 plus SNR. So you have to find out first the this noise ratio, SNR ratio. Okay, so SNR ratio, you have to first calculate this, and then you have to find out your channel capacity. C is your channel capacity and B is your baseband. Okay, now baseband, the baseband of log base to 1 plus SNRL. Okay, now using this formula you have to find out. Okay, so after this is your, and then next class I will explain the next part. Okay. Hello. Okay, so I will take your lab sessions. That is the, it will be started from 4:15. Okay.
চারটে পঞ্চাশ তো
4:15. চারটে পঞ্চাশ হলে হবে কি ওটা?
আচ্ছা 15
4:30
ওকে
4:30 থেকে শুরু করছি, ঠিক আছে? 4:30 to 5:30 মধ্যে শেষ হয়ে যাবে। Okay, after this is clear to after this your class. Hello.
হ্যাঁ স্যার
Okay. you give the attendance to your chair, okay, everyone. So Isita तो है नाम okay, so everyone have to give the attendance to your chair. Okay, I am